So continuing on to the video, guys, what we were saying was that line, the green line that connects points A and points B together across this function is called a chord. And so what the mean value theorem has said, as long as f is continuous and is differentiable, we can go ahead and find a parallel line to the chord specifically. And so our goal is kind of looking into this one today. We're going to kind of really use the mean value theorem as a way to kind of explore if a function or not fails or satisfies what it kind of entails inside that mean value theorem specifically. So let's kind of look into a first example in regards to this. So looking at it, we want to decide if the function fails to satisfy mean value theorem's kind of requirements over the interval. So decide if the functions fail the mean value theorem over -1 to 1. So let's think here for a second. Well, basically what we need to end up just showing is, is the function continuous? Is it going to be differentiable over the open interval? And does the instantaneous, are we going to be able to find an instantaneous rate of change that equals the average rate of change from -1 to 1? So let's say the first function that we are dealing with here is f of x equals the square root of x squared plus 1. Well, the first thing I notice in this particular example, guys, is that the square root of x squared is just the absolute value of x, because you can substitute negative x or positive x into that value and get the exact same result when it's all said and done. So really, this function looks just like this. And why is that important to us, and why is that a little bit more meaningful? Because that's just the absolute value with a simple vertical shift of up 1. And so really, this particular function is looking right here. We know we have our bottom there. We go out, and we go out from -1 on to 1. And so because of what's happening here at that corner, remember, this is a problem here when we have these corners, because we don't know what tangent line that we are really dealing with. And so that gives us a little bit of an issue in this particular example. And, that's kind of right off the bat failing the mean value theorem to answer the question, because it's not differentiable at this corner. So not differentiable at this corner or when x equals 0. So yes, this fails requirements for mean value theorem. The next example I want to look at, next function I want to look into for this exact same type of question, but we're going to look at a piecewise function of f of x equals x cubed plus 3, x squared plus 1, and it's x cubed plus 3 when x is less than 1, and it's going to be x squared plus 1 when x is greater than or equal to 1 in this particular example. All right, so will this work? Will it not work? Well, remember, think about what it means for a function to be continuous, right? Remember, for the function to be continuous, it has to have the same limit approaching from the left and the right-hand side, and that limit has to equal specifically f of c. And so we gotta first kind of double check what that limit is going to be in both cases. So let's just check that limit. The limit as x is less than 1 is going to be from that left-hand side. So when the limit is less than 1, we see that 1 cubed plus 3 equals 4. And then 1 squared plus 1 for the right-hand side is equal to 2. And so that's not going to work. So this is not continuous and will fail the mean value